Okay, so for this lesson, we have solving radical equations. So here's what the radical looks like. Radical is a root symbol with anything that's inside of it. For this question, my first step is to isolate the radical. As long as you stick to the correct steps, you should be fine. I'm going to always highlight my radical so I can see what I'm trying to isolate. In this case, I'm trying to isolate this part. That means the 2 and the 4 are not part of my radical, but the 4 is on the other side of the equal sign, so I'm not worried about the 4. I'm worried about that 2. If I need to get rid of this 2, notice it's on the front of the radical. That means it's multiplying my radical. The opposite is to divide by the 2. Now I have the square root of x plus 1 equal to 2. So it looks like my radical is isolated. There's nothing outside of it on the left side of my equation. So I can move on to the next step, which is to eliminate the radical. That means I get rid of the root symbol by raising each side to the same exponent. That means we're looking at the n value. My n value, if you remember, it's a to the m over n. Or if you have it in radical form, n is the number in the outside when a is on the inside. So in this case, I'm looking at the n value out here on the radical. If I don't see a number, we know it's the square root, so the radical or the index is 2. So if I'm going to eliminate, I'm going to raise each side to that exponent. That means I have the square root of x plus 1. I need to give it the exponent of 2. And whatever you do on one side, you do to the other side. My radical is eliminated. I'm still left with whatever is inside. And I get this part left. So it looks like I did eliminate the radical by giving it the same exponent. 2 and 2 cancel each other out. And I'm left with x plus 1 equals 4. My next step is to solve for x. That means I need to get this x by itself. So it's kind of like this first step where we isolate the radical, but now my radical is just x. If I want to isolate it, I need to get rid of the plus 1. So I do the opposite and subtract 1 from both sides. And I get x equals 3. To check my solution, you plug back into the original problem, which is 2 radical x plus 1. But instead of the radical, I'm going to plug in my x value, which is 3. So parentheses 3. We're going to put this exactly how we see it on the calculator. This whole thing. Without the equal sign, we type it in the calculator exactly how we see it, and it should give us the answer to be 4. We get that from the calculator. If it's the same thing as my original problem, that means this is not an extraneous solution. An extraneous solution is a solution that does not work. That means it's a solution that does not give you the same answer back, which is not going to be on this lesson. So for this one, we're always going to say no. My solution is not extraneous. And my solution is x equals 3 because I'm always solving for x. All the questions will always have the same steps. So even if they look a little bit different, kind of like this one, even if it looks a little bit different, we're still going to do the same thing. We're going to isolate the radical. I'm hoping that you can make the connection that this is the same thing as the 3 at the front, 3x minus 1. I don't really put the exponent of 1 because it's not necessary, but this is my radical. This is my radical. It's an exponential form, but it still works. So I need to isolate that. That means I need to move the 5. On this problem, I subtract the 5 because it was being added. But on this problem, I divided the 2 because it was being multiplied. So we always do the opposite of what it's doing to get rid of that number. All right, so back here. Once I subtract the 5, I get 3x to the minus 1 to the 1/3 equals to negative 4. My next step says eliminate the radical by raising each side to the same exponent. Remember, we're looking for the n value. That's what my exponent should be. On this problem, I know I don't have a radical, but remember we talked about how you can rewrite it in radical form, go from exponential to radical. Here's how we convert it. So my n is what I use as my exponent. My n right now is that 3. So if I raise it to the 3rd power, that 3 and the 1/3 will cancel each other out, just like it would have in radical form. So I do eliminate the radical. I'm left with what's on the inside of the radical, that 3x minus 1. And that's equal to negative 4 to the third power. Put that on the calculator. We get negative 64. And then from here, it should be easy work because we're solving for x. We're trying to get the x by itself. So we draw the line. First, we add or subtract. And then the last step is almost always to divide. We get x equals negative 21. You always have to double check that your solution works. To double check it, you plug in your answer back to the original problem. Make sure you put it in with parentheses, 3x. My x is negative 21 minus 1 to the 1/3 power plus 5. We put this whole thing into the calculator. Make sure that that is equal to the one that I have here. These have to be the same. I got this one from the calculator. I got this one from the original problem. Because they are the same, the answer is no. We do not have extraneous solution for this problem. And my answer is x negative 21.